Hey everyone, in this video, I'm going to discuss about introduction to database. Very first thing, let's understand what exactly is a data. Data is any information that can be stored, accessed, and updated. It can exist in different ways. It can be in a physical form, just like papers, or in a digital formats like a files. Essentially, data is everywhere. What we see, what we hear, or see can be categorized as a data, right? So we have a different data formats such as like images, videos, text files, documents, compressed files, executable files, and etc. So now, what are the different types of data we have seen? Majorly, there are three different types of data, okay? Structured, unstructured, and a semi-structured data. When it comes to a structured data will have a predefined format, which is organized systematically, making it easy to search and process. When I say structured data, any data which is stored in the form of a table format, we call it like a structured data. Okay, there will be different rows and different columns. When someone asks for your details, you respond in an organized way. We call it like a structured data. The most common formats of structured data is like CSV format or an Excel format. CSV, comma separated values. Excel files, already you people know that, right? So the next type of data type is basically, unstructured data. When I say unstructured data, it lacks a predefined model or an organization, making it harder to analyze and manage. Imagine a messy bedroom where everything is scattered around. That's unstructured. To structure it, you need to organize items into a categories so it becomes easy for you to understand, right? The common formats are like a text files scattered everywhere, media files, HTML, PDFs. These are all, unstructured data which lacks a proper structure. The third type of data is basically, semi-structured data. Semi-structured data is a type of data that doesn't follow a strict, rigid structure, just like your structured data, but it still contains some pattern. It has some structure, it has some organization hierarchy, which makes it easier to analyze than unstructured data. Structured means like a table, unstructured means no structure at all. When it comes to a semi-structure, there will be certain format, we call it like a JSON. JSON in the sense, it's a list of dictionaries. Key value pair. If you are storing information like a key value pair, if you have such multiple dictionaries, we just call it like a JSON data, which is a semi-structure. See like this. Name colon John, age colon 30. So this is a JSON data. JSON data usually to store information related to a website, it will be like a semi-structured format. I hope it's clear. Great. So now the question is where exactly the data is stored. Data storage has been evolved over a time, starting from physical records to advanced cloud system. So initial days, people used to store it in a physical storage like notebooks, papers, files. Then switched to personal devices like phones, laptops, tablets. Then external devices like pen drives, hard drives, memory cards. Then started with cloud services like Google Drive, OneDrive, Dropbox, iCloud, etc. And also we have a different data transfer methods such as like a Bluetooth, USB cables, Wi-Fi, etc. Right? So when I come to the enterprise level data storage, for personal usage, yeah, obviously we can store it in folder files, which are efficient because relatively small amount of data we are storing. But when it comes to a company level, organization level, the data generated will be very huge. It will be in terms of terabytes, right? In that case, high frequency of data is generated. Advanced security system is important. So in that case, we just go with a enterprise level data storage like a data lakes. Data lakes is responsible for storing unstructured data. Data warehouses are responsible for storing structured data. So there are cloud platforms like AWS, Azure, Google Cloud, which provide scalable and secure storage. So whenever you want, you can increase, decrease according to your requirements, and you can also secure it because security for data is super important, right? So examples, data is a backbone of a decision making. So when it comes to an examples, e-commerce platforms like Amazon, Flipkart generate huge amount of data, transaction data. Social media, Facebook, Instagram stores like generates a lot of data that is storing in data lakes. Healthcare, hospital management, patient records, images, reports using secure and compliant system. So like this, different industries are generating different amounts of data and everything is getting stored in a different way. Okay, since data is backbone of decision making in today's world, whether structured or unstructured or personal or enterprise level, managing it is very much crucial in this current world, right? Yeah. So now let's understand what exactly is a database. We all know that imagine your phone's contact app as a mini database. Without it, Obviously, it would have been really difficult for you to find the phone numbers. You might have written, books, notes, sticky notes, scribble names, phone numbers scattered everywhere, and kept it in a drawer, wallets, or maybe even the back of receipts. Finding someone's contact would be an absolute nightmare before an introduction of our phones. But with your contact app now, your personal database, everything is neatly stored. Names, numbers, email. You can also add a profile pictures too, right? If you want someone's number, you can just type their name. It just gives you the result. So, what is database? Database is an organized collection of storing, enabling easy access and retrieval, which helps you in manipulation of information. So, we have a different types of databases. Majorly, we have two different types. One is a relational databases, wherein data is going to store in a table format. You will have a different rows, different columns. Any database which stores an information in the table format, we call it like a relational database. We have a different relational databases like MySQL, PostgreSQL, Oracle, etc. And the modern relational database management system. It's a software which helps you in managing, manipulating large amounts of data stored in a structured format. So database is place where we are storing, but in order to manage it, in order to interact with it, obviously we need some software, right? That is a RDBMS. They provide way to organize, store, retrieve data efficiently and are widely used in industries such as like finance, healthcare, e-commerce, because these industries are generating huge amount of data in a structured format. So different RDBMS are like MySQL, which is an open source, widely used for web application. PostgreSQL, this is another open source RDBMS known for its advanced features. Oracle proprietary database owned by some specific company, Microsoft SQL Server. Even this also proprietary RDBMS is developed by Microsoft. They're like a paid ones. So MySQL Postgre has an equal importance. If you learn any one skill, you can similarly implement. You'll see only a little changes, probably in interface and some SQL commands. Okay. So when it comes to the non-relational databases, it stores data in a JSON format, just like a dictionary formats. Examples, we have a MongoDB, Cassandra, and a Redis. This is how the relational database look like. And non-relational is going to store information in a dictionary format, wherein you will have a different key and a values. I hope this is clear. So now you might have a question like difference between relational and non-relational. So very first difference is in relational data is stored in a table format, but in a non-relational it is stored in a key value pair. When it comes to the scalability, relational databases scale vertically. That means we try to increase or upgrade a single hardware to handle the increased workload. When it comes to the non-relational databases, we have to scale it horizontally. You cannot upgrade the single system. You have to introduce multiple systems to handle the multiple loads. Okay. So simple example to understand this. Okay, flexibility wise, sorry, simple example is data stored in table means like it's a relational database to handle more usage of data. Let's say, for example, when it comes to the banking system, as the customers increases, the customer details are increasing. If the bank grows, it might upgrade the same server with more RAM or a CPU. But there is a limit to how powerful one machine can be. So we call this as a vertical scaling. Upgrading same computer, making it more powerful with more RAM and CPU. We call it like a vertical scaling. This is going to happen in a relational databases. When it comes to the non-relational databases, it's like a big online dairy. Okay, where data is getting stored in a key value pair. Great when data type grow very fast social media content like Instagram, Facebook, YouTube, for all this information. Non-relational plays a very important role. So when I say scaling horizontally, we're gonna add more computers to share the load because we don't know how many people are going to register for Instagram every time, right? Social media app like Instagram stores post, photos, comments, all different types of data. So we use a JSON. As millions of users join, and Instagram can just add more service to handle it because it cannot handled by the single server because millions of people are using it, right? Every day, million of people can create an account, they can delete. Lot of things are happening over the internet. We call it like a horizontal scaling. Vertical scaling means upgrading single system. Horizontal scaling in the sense like adding multiple servers to balance the load. Okay, it's like making one computer stronger, that's a scale up. Adding more computers to help, that's a scale out, which is horizontal scaling. Flexibility and a schema wise, obviously, relational databases are flexible schema to store, modify, and all. Non relational databases are schemaless design, not that effective, flexible for you to analyze it, right? When it comes to the programming languages, it has a different languages like relational database uses a SQL language for interacting with data, and non-relational databases uses a MongoDB query language. So, wherein SQL is critical for data analysts and data scientists who frequently work with a structured data. When it comes to the MongoDB query language, it is useful for the developers who are trying to build applications requiring flexibility in data handling. Okay, this is all about an introduction to databases. I hope it's clear. Thank you. Happy learning.